Hello, in this lesson we're going to learn about higher derivatives. It really just means you take derivatives of derivatives, so there's really nothing new in terms of technique. However, we are going to eventually learn a lot of neat things that can be expressed with higher derivatives. So first of all, the definition. The second derivative has two alternate notations. One notation is written as f double prime. Another way to write it is with a power 2 in parentheses. So those are just different ways of writing the same thing. And all it means is you take the derivative and then you take it again. That's it. Third derivative, similar. Similarly, two notations. 3 hash marks, or with a 3 in parentheses. And what it means is you take the second derivative and take the derivative again. So that's it. Since we know how to do derivatives, there's nothing really new. Obviously, you can do 4th, 5th, as high as you want for derivatives. All right, let's do an example. Let's consider the function f of x equals x e to the x and start doing higher derivatives, or, well, derivatives first. So the first derivative can be written this way with a parenthesis around the 1, or in our traditional notation, f prime of x. And what you do is use the product rule, so take the derivative of the first term, leave the second alone. Then you leave the first term alone and take the derivative of the second term. And you can factor out here a 1 plus x for e to the x. So that's the first derivative. The second derivative can be written this way. Can also be written this way. And you take, here's the first derivative over here. So it's a product rule again. Take the derivative of the first term, so that'd be 0 plus 1. Leave the second alone, and then leave the first term alone, and take the derivative of the second. Factor out the e to the x, and you'll see now we'll get 2 plus x e to the x. Let's do a third derivative here. The third derivative is written this way. And again, it's the product rule. So we do the derivative of the first term, leave the second alone, and then we leave the first alone and do the derivative of the second. Factor out the e to the x, and you get 3 plus x e to the x. If you mess around longer, it's pretty easy to see that there's a pattern developing. The pattern is simply this, that the nth derivative of f is actually n plus x e to the x. So that's the general nth derivative. All right, let's do one more example. Before I do that, I just want to remind you of factorial notation. So remember, n factorial just means you do n times n minus 1 times n minus 2 all the way down to 3 times 2 times 1, and that's n factorial. So here's the example. Let's look at f of x equals x to the minus 1. Then the first derivative, the minus comes down, so we get minus x to the minus 2. Then the second derivative, we do the derivative of this term here that we just took the derivative of. We get another minus coming down, so the two minuses cancel, and we get a plus 2. I'm going to write times 1, even though it looks strange at this moment, to the x to the minus 3. Third derivative, now we do the derivative of the second derivative. So a minus 3 comes down. Instead of multiplying, I'm going to write them out like this. Let's write one more. So the fourth derivative, we get a minus 4 coming down. So it's 4 times 3 times 2 times 1. X to the minus fifth. And so as you see this, now the pattern really emerges that these coefficients are factorials. So in general, the pattern is this, that the nth derivative has an n factorial coming down, and you notice that the power of x is always one higher than the n. So the 3 became a 4, the 4 became a 5, and the n will become a minus n plus 1. And then we have this alternating sign we still have to deal with. A plus, minus, plus, minus, plus. Well, in math, frequently the way you handle that is with minus 1 to the n, or n plus 1. In this case, we want minus 1 to the n. So checking here, when n is equal to 1, we get a minus 1, good. When n is equal to 2, plus. When n equals to 3, minus. When n is equal to 4, plus. And anyway, that's the pattern. And that's higher derivatives.